Good morning, and welcome to our Alaska Collaborative on Health and the Environment teleconference with guest presenters Bjorn Beeler and Dr. Andrea Gore, titled An Introduction to Endocrine Disrupting Chemicals, New Resource on Health Threats Posed by EDCs. My name is Diana DeFazio, and on behalf of Alaska Community Action on Toxics, I'll be facilitating today's call. CHE-Alaska is a regional partnership group of the National Collaborative on Health and the Environment. CHE-Alaska aims to advance knowledge and effective action to address growing concerns about the links between human health and environmental factors. You can find more information at akaction.org and healthandenvironment.org. And everyone who signed up for the call should have received an email from me either yesterday or this morning with a link to today's presentation slides. This is not actually a webinar, but a teleconference with supporting materials, and you have to click through the PDF as the speakers go along. It's really quite easy to do. If you don't have that link in front of you, you can access the PDFs on our website. Go to akaction.org, click on the announcement for today's call, which will bring you to the call webpage, and towards the top, there are links to both of the presentations. And Bjorn Beeler will be presenting first. The call will last 1 hour with time at the end for your questions. So as a participating organization of the International POPs Elimination Network, or IPEN for short, and steering committee member, Alaska Community Action on Toxics is really pleased to welcome and introduce Bjorn Beeler, who is the International Coordinator and General Manager of IPEN, which is a global network of nearly 700 NGOs in over 100 countries working to advance international chemical safety policies and implement them at the local and national levels. Mr. Beeler has 13 years of experience in United Nations environmental policy negotiations and international development aid projects in 6 continents. He holds a master's degree in environmental sciences from Lund University, Sweden, and a bachelor's degree in economics and anthropology from the University of California, San Diego. A warm welcome to you, Bjorn. You may go ahead and begin.
Great, thanks, Diane. I'd like to first thank CHE-Alaska and ACAT for organizing this webinar. As the issue of endocrine disrupting chemicals is really an emerging issue that there's a lot of interest within the global network of IPEN. I prepared a presentation with a lot of slides, which I'll move through swiftly, and it's also kind of a reference for after the call for people to look at. So if we start the first page, it's titled the IPEN Endocrine Society Collaboration, an initiative to raise global awareness on endocrine disrupting chemicals. I really hope everyone's had a chance to look at the guide, which is the image on the right. It's also downloadable at the URL at the bottom, and that's what most of this call is about. I thought I'd first give a brief overview of what IPEN is, what it means. So on the next slide, you'll see IPEN's mission. And IPEN's mission is essentially a toxic-free future for all. And this is the focus of the organization and the network. And if you go to the next slide, it gives an overview of the stretch of the network. The yellow dots indicate where we have regional offices operating in the UN language, so Francophone Africa, French, Latin America, Spanish, and so on. And there's 2 international offices. I'm in Berkeley, and we also have an office in Sweden where IPEN's registered. Now, the make of the network, if you go to the next slide, is a majority of the organizations in IPEN are public interest organizations. Some are health organizations, some are grassroots organizations. And the main themes these groups work on are where their communities have been impacted. The main general themes relate to pesticides, waste, and contaminated sites or industrial pollution. So that's the base of IPEN. And as you saw in the earlier slide, the majority of IPEN's organizations are in Africa, Asia, and Latin America, where they're getting confronted by chemical exposure in very direct manners. And the next slide just gives an idea of the stretch of the organization as far as regionally how it's balanced. That image there is of the current IPEN co-chairs, Olga Sperinskaya and Manny Kalanzo. Olga is from Russia. She's a 2009 Goldman Prize winner, so she's quite accomplished within the region of the former Soviet area. On the next slide, global increase of chemical production and use. This is important because what we've seen is a rapid growth. So the chemical industry is growing rapidly worldwide, especially in developing and transitional countries. Today, chemical companies are among the richest corporations in the world, with gross global sales estimated at over now $4.1 trillion, which was in 2010. And that's a growth from 17 billion in 1970. These are the numbers provided by the industry themselves. Most of all developing and transitional countries, which I'm referring to as basically the countries in Africa, Asia, and so on, are increasing their use of pesticides and industrial chemicals. As a result, toxic pollution is increasing and represents a rapidly growing percentage of the waste stream. Through a patchwork of national laws, voluntary programs, and international agreements that address chemical use throughout the world, these systems are by and large insufficient given the industry's international reach and complex of the product mix. Because many hazardous substances travel via air currents and through the food chain and through trade, every individual is maintaining some level of toxic exposure in their bodies. Strong global and national regulatory systems are critical for citizens across the globe, wherever they live. For example, the chemical industry of the world's #1 producer and exporter of goods, China, is set to grow by 66% since 2012 to 2020. This information is available in the 2012 UNEP Global Chemicals Outlook. So all to say, it's growing, the sector is growing rapidly, exposure is growing rapidly, and most of the growth is taking place in countries with inadequate systems to protect exposure. So if we go to the next slide, it says IPEN's theory of change. So amongst the NGOs, or say the public interest groups in IPEN, IPEN focuses on drawing them together to engage in international law. So how do we globalize local priorities into global chemical policies? And through that process, we educate and orient groups in drawing their situations and give them a voice, or provide a venue for them to have a voice in the global arena. And thereafter, we focus on localizing the global policies and leveraging global policies to mobilize resources for on-the-ground activities and change in national chemical regimes. The next slide briefly is just the program areas of work, which are essentially global treaties, and the other ones has to do with stronger chemical national regimes promoting chemical safety, as well as we work on toxic metals, mercury and lead, mainly lead paint, eliminating lead paint. And then also within the network, we focus on building capacity and expanding the movement into other sectors. I'll say a few things about what this looks like in real terms, which draws us into the EDCs issue, is the global policy arenas IPEN is working on is the Stockholm Convention on persistent organic pollutants like DDT, dioxins, and brominated flame retardants, the Basel Convention on the transboundary movement of hazardous waste, the Rotterdam Convention on prior informed consent, and the Minamata Convention, which is on mercury. In addition, there's this term called SICOM, the Strategic Approach to International Chemicals Management, which is the framework where EDCs has emerged into the global policy arena. This essentially, SICOM has to do with building up national chemical regimes through using development aid and development resources. EDCs on the global policy agenda. So within SICOM, there's a space to raise awareness about emerging issues such as nanotechnology or chemicals and products, and EDCs has emerged as one of those issues. As it states here in the slide, in 2012, the resolution was passed, and there's a quote here, but essentially, by 2012, representatives from 122 governments, 19 international organizations, which are essentially UN organizations, and 79 NGOs at the Third International Conference on Chemicals Management formally adopted EDCs as a SICOM emerging issue. SICOM considers an issue to be emerging if it has not yet been generally recognized, is insufficiently addressed, or arises from current scientific information and includes adverse effects on human health and the environment. In practice, an emerging issue becomes relevant as a priority issue for global action. At this meeting in 2012, the resolution on EDCs was the first time EDCs were elevated to the global level, and the first time that the global community recognized by consensus this quote here, which is potential adverse effects of endocrine disruptors on human health and the environment. and the need to protect humans and ecosystems from their and their constituents from parts from that are especially so protecting vulnerable communities. It says here that's non-legally at the bottom, which is important because SICOM is a non-legally agreement, a non-legally binding agreement. The Stockholm Convention and the other treaties are legally binding, but SICOM creates a framework. If we go to the next slide. Without getting into all the details, I've provided it, and I don't want to read each one, but essentially this is a program of action that was adopted by the global community in 2012. And out of that process, UNEP, which is the United Nations Environment Program, has established a group to begin to define what activities UNEP could do in the long run. It creates a framework for donors as well, international donors, to justifiably support activities in this arena as well. I'd like to draw everyone's attention to point number 2, which is raise awareness at all levels. And this, to one degree, is the focus of the collaboration that we entered into with the Endocrine Society around EDCs. On the next slide, this is just an illustration of now with the global agreement that action is needed on EDCs, focusing on raising awareness and orienting individuals around what EDCs are. IPEN began conversations with representatives of the Endocrine Society, which is identified as the science leader on EDCs. If you go to the next slide here is just a brief about the initiative. So I'm on a slide that is titled ES-IPEN Initiative Global EDC Awareness. So in this, we began conversations with Endocrine Society representatives and came with a strategy of developing a mechanism for raising global awareness. In this, we defined what the target audiences would be. So these would be public interest groups working on chemicals issues, as well as policymakers in developing and transitional countries. So amongst many of the NGOs that IPEN works with, when we worked on persistent organic pollutants, those NGOs' entry points into persistent organic pollutants was really through mainly their work on waste and the issue related to dioxin, or on DDT or other POPs pesticides and their work related to pesticides. So now we are trying to educate and orient them around the dynamics about what EDCs are. It's a new terminology for many of these NGOs, and there's a lot of interest in it. With regards to the scope of the guide, it was designed that the Endocrine Society is the lead, it has the lead in science on EDCs. And so all the content on science would be generated by the Endocrine Society. And there is it says ES, which is the scientific statement that is leading the Endocrine Society as an institution, plus the 2012 WHO UNEP State of the Science Report, which several Endocrine Society members were co-authors of. So we defined who would lead and how would we develop the guide. And the Endocrine Society established a team led by Andrea, who was speaking next, and other health authors. And IPEN developed a team of individuals across the globe with knowledge of SICOM, with the policy arena, as well as perspectives from how this could be digested from a global South perspective, or say from a perspective from NGOs in Asia, Africa, and Latin America. And then the other element was that we wanted to do this as a joint production. And doing it as a joint production, IPEN has been working in the scientific arena, or in the policy arena since 1998 during the negotiations of the Stockholm, and within SICOM since 2003. So we have a level of, we are a very relevant stakeholder with regards to public participation in the development of these negotiations. And the Endocrine Society is well identified as a leader in science. So how do we put these two together? And we thought to do a joint production and dissemination of this. If you go to the next slide, it's about chapters. I won't go into this much, but this is how we design the chapters as far as what were key elements to raise around EDCs in a broad sense. And the items here, and again, I hope everyone's had a chance to look at the guide. Without going into it, the key point is, if we get to the next slide, is how do we make EDCs seem relevant to groups working on issues? And in the next slide, saying key points, we wanted to show where you're getting exposure and how they're getting exposure, as well as link those to chemicals that groups have already been working on. So the chemicals identified and pesticides, DDT is one that many groups have been working on, and chlorpyrifos is a priority chemical amongst the NGOs for attention. Children's products, many groups have been working on exposure to lead and mercury through children's products, so that also had relevance, as well as the other items that are mentioned there. As I move on to the next slide, I just wanted to give some images from the guide itself, and I won't read the quotes, but these are very powerful quotes that illustrate the importance for paying attention to EDCs and raising awareness around EDCs. And we thought that these images were very useful in drawing attention, as well as highlighting key callouts from the guide itself, which are also echoed throughout the document. So if you go through, you flip through some of these images, I think one key one to raise is near the end. And I'm suggesting people to look at this later on through the guide. But the third to last slide, which is talking about, it says, it's a chart. It says traditional approach to chemicals testing, the dose is the poison, and why this approach is insufficient for endocrine disrupting chemicals. It's slide 25. I'm not sure if you can tell on the form you're looking at. This is very important because it begins to illustrate the old science versus the new science. And as you'll learn more from Andrea's presentation, there is a need to address EDCs in a different paradigm than the current paradigm because there's low dose effects to mixture effects that doesn't fit the current chemical policy regimes and how they're addressed nationally. And then the second to last slide here, as I begin to wrap up, is kind of next steps for the guide. Right now, the guide is under translation for Spanish and French, and then Arabic, Chinese, and possibly Portuguese and Russian are other languages that we're aiming to get into. And then conduct regional webinars in these different languages as well as English to educate and inform NGOs, which we identify as key actors in raising public awareness as well as media awareness, as well as creating an environment for political engagement around EDCs, as well as country delegates in Africa, Asia, Latin America, and the former Soviet region, to raise their awareness about why there's a need to pay attention to EDCs and to begin to understand them. And then global monitoring, and the last item here is global monitoring. This is a long-term. I put here IPEN plan as an institution. And there's others who may be also interested. It's another way of raising awareness around where do you find EDCs and how do they relate to the exposure. So with that, I think I try to stay within my time here swiftly. I'd like to thank everyone for your attention. With that, I'll pass it back to you, Diana.
Okay, thank you, Bjorn. And I do want to remind everyone that the guide, there's a link to the guide that was sent in the email with the call-in instructions. It's also on our website under resources on the call webpage, so you'll definitely want to download that if you haven't already. And before introducing Dr. Gore, I'd just like to remind everyone that there will be time for your questions at the end of the call. So if something came up during Bjorn's presentation, or if you want to go back and look at one of those messaging slides a little bit closer, make a note of it now so that you can ask later. And now it's my pleasure to welcome and introduce Dr. Andrea Gore. Dr. Gore is Professor of Pharmacology and Toxicology at the University of Texas at Austin and Editor-in-Chief for Endocrinology. She was the lead author on the Endocrine Society's scientific statement on EDCs in 2009 as well. Dr. Gore specializes in reproductive neuroendocrinology and the mechanisms by which the brain controls reproductive function. Dr. Gore earned her PhD in neuroscience from the University of Wisconsin-Madison and a BA in biology from Princeton University. Welcome, Dr. Gore. You may go ahead and begin.
Yes, thank you. I hope you can hear me okay.
Yes, you're on.
Okay, well, thank you. First, I'd like to thank Diana and Kay Alaska for inviting me to participate in this session. It's been an interesting experience from the scientific side of the world of EDCs to work together with IPEN and Bjorn and the rest of the group on communicating both the scientific perspective as well as the public health and the international community consequences. So what I'm going to be focusing on today is the scientific side of the story. And I've numbered my slides, so I can give you the slide numbers as we go through. So moving to slide 2, let me tell you just a little bit about the Endocrine Society, which is the organization that has really stepped into a leadership position in terms of reviewing the science, determining whether there is adequate science, determining what are the health effects of EDCs in humans, and trying to understand and make connections between basic research, work that's done in a lab in cell lines and in animals, and connecting that to disease conditions in humans. So the Endocrine Society really has just the ideal kind of expertise because it's a mixture of clinicians who see patients, clinical investigators who do research on people or see people who present with certain endocrine diseases, try to understand the cause of those diseases, and basic researchers such as myself who are trying to investigate underlying hormonal mechanisms. So the Endocrine Society is going to be celebrating its 100th anniversary next year, so it's very well established, has about 18,000 members, and the expertise in EDCs is very much subsumed in the Endocrine Society. So let me give you just a little bit of background about how the Endocrine Society came to be involved in the science of EDCs. Back in 2005 at their annual meeting, there was a forum on endocrine disrupting chemicals, EDCs, that took place in San Francisco, and that was really the first time that a scientific society of the size and of the importance of the Endocrine Society really addressed this question of health concerns, endocrine concerns about EDCs. And there was a tremendous amount of interest, and it became clear to the society that this was a very important topic for them to be able to have an influence, because endocrinologists are the people who really understand how hormones work. And so we have a unique type of expertise for understanding what happens when there's disruption of those hormones. There was a second forum on EDCs in 2009, and then in 2008 to 2009, a working group published the first scientific statement on endocrine disrupting chemicals that was very influential in calling attention around the world to this problem. And many medical societies, and I've listed a few at the bottom here, but those include the American Medical Association, the World Health Organization, and the UN Environmental Program, and others, either endorsed the principles that were in that statement or came out with statements of concern on their own for their patients. So if you go to slide 4, I'd now like to give you the background about the Endocrine Society's role in putting together this guide to endocrine disrupting chemicals. We had a working group of 6 scientists listed here. I won't go through the list, but you can read them and you can look up all of our expertise. All of us are investigators doing active research in the field of endocrine disruptors, with the exception of Loretta Doan, who is an expert scientist who's been working at the Endocrine Society on this issue. But the rest of us do the research in our labs, we know the literature, and we're also very interested in communicating it to not just the scientific audience, but also the stakeholders, the people who are out there who are being exposed to chemicals, which really is everyone. So let me give you a definition of an EDC as defined in a statement of principles from the Endocrine Society in 2012, led by Tom Zeller. An endocrine disruptor is an exogenous chemical or a mixture of chemicals that interferes with any aspect of hormone action. So let me tell you about how we get exposed to EDCs and how they work. Slide 6 summarizes many of the common ways by which we get exposed to EDCs through chemicals in our home, through consumption of food and beverages that during processing can have chemicals introduced to them. Also, containers of food and beverages, can liners, plastics that contain food and beverages are made up of chemicals, and sometimes those chemicals leach into the food, even though that was never the intention. Personal care products that we apply to our skin and to our bodies, and pesticides are also very common routes of exposure. And I've shown in some of these pictures some of the sources. Of course, industry has brought a lot of chemicals into the environment, not necessarily intentionally, but products that were synthesized and then stored and in many cases not disposed of properly have leached into the soil and gotten into the water. And then, as is depicted in this little picture in the middle, there's a food chain where there are spilled chemicals getting into water, being eaten by smaller animals, getting into plants, and ultimately getting into people. So going on to slide 7, this is from the guide, and just very quickly, let me tell you a little bit about hormones and endocrine systems. Hormones are secreted by a group of glands in our body, many of which are listed here. And the endocrine glands release these hormones directly into the bloodstream, so they circulate around our bodies, and then they act at specific targets to regulate some sort of a biological function. So as an example, we have the thyroid gland here shown at the base of the throat of a man or a woman, and the thyroid hormones are released into the general circulation, and then they target cells that express receptors for thyroid hormone. And since thyroid hormone regulates metabolism, these cells are affected by the thyroid to engage in processes that control our metabolism, things like our energy balance, weight gain and weight loss. Many of these processes are controlled by the thyroid gland. So what we're beginning to learn from the field of EDCs is that so far all of the research on the different endocrine systems, the endocrine glands, suggests that all of these systems are vulnerable to EDCs. Now, only certain systems have really been studied in depth, and so those systems include reproductive systems, the brain, the mammary glands, the thyroid system, and several others that I'm going to be talking about. But we believe that these other systems in the body are vulnerable as well. So going on to slide 8, there are several key principles that are important for understanding how hormones and EDCs work. So first of all, endocrine systems are absolutely essential for survival. They're needed while we develop. Our body releases hormones that are very important for development. Hormones are necessary for reproduction, and our health throughout our lives are maintained by endocrine hormones. So because hormones are so important for many of these functions that keep us alive and keep us healthy, we know that EDCs that can either mimic effects of hormones or block the actions of natural hormones can interfere with the endocrine systems, and hormone production, release, and metabolism can be perturbed. Another concept that people don't often think about in terms of what does the endocrine system do, why did it evolve, the endocrine system is one of the major body systems that allows us to interface with the environment. In other words, we need to constantly respond to environmental change. When it gets hot, we need to cool down. When we're hungry, we need to eat. When we're being chased by a predator, we need to run away. And all of those are environmental challenges, environmental stressors. And we also know that chemicals are part of the environment, the external environment. They get into our body, they become part of our internal environment. And so that's one of the reasons why endocrine systems are so sensitive to EDCs, is because their function of interacting with the environment is a fundamental property of how they work. Another important concept that I will underscore here and in subsequent slides is how early developmental stages, particularly the fetal development and infant development in childhood, those early life stages are extremely sensitive both to natural hormones as to EDCs, as well as to EDCs. And so there's a phrase in toxicological testing where scientists evaluate the toxic effects of a chemical, and many times they'll say the dose makes the poison, meaning a higher dose will be more poisonous than a lower dose. However, what we say as endocrinologists about EDCs, that the timing also makes the poison. Developmental exposure is a time when we're particularly sensitive to EDCs and when they can be most devastating. We also know that a single EDC class can act at many different kinds of target cells and tissues. and hormones and EDCs interact and may have very complex health effects that may not be seen right away, but can be observed days or weeks or even years or decades later in some cases. So moving on to slide 9, I won't spend any time on this, but I put this into your slide set. It's from the guide, talking about this special vulnerability of the fetus, infant, and the child. And the hypothesis that we invoke is what is called the developmental origins of health and disease, or DOHAD, which makes the point that early development is very vulnerable to hormones and EDCs, that exposures during those life periods cause changes that can play out later on in life as the increased propensity to develop some kind of a disease. So hence the developmental origins of health and disease. Slide 10 begins now going through more of the science. So the guide focused on 3 different classes of chemicals: pesticides, products, including children's products and electronics, and food contact material that were written about by the authors of the guide. And in pink, I've highlighted those chemicals that I've chosen just for the sake of time. I didn't have time to go through all of the examples. Maybe if there's time later, depending upon how long it takes me to finish up, I can also talk about chlorpyrifos, since Bjorn mentioned that that's an area that IPEN is particularly interested in, and it's a chemical that is still very widespread. Even though it's banned for certain uses in this country, it's still out there. So moving on to slide 11, let me talk about the representative pesticide I chose to focus on, which is DDT. It is an insecticide that falls in the organochlorine class, and I inserted a picture of the structure just so you can see that it has a number of chloride, abbreviated Cl, molecules attached to a more complex molecule that has some rings. And something about this ring structure of this molecule that's important is that many, if not most, of the EDCs that we know of have some sort of a ring structure. And this ring structure is common to many different hormones. For example, hormones like estrogen, testosterone, progesterone, cortisol, and others have ring structures. And we believe that these EDCs, because they have this ring structure, can trick the hormone receptors into thinking that they're being bound to a hormone when in fact they're being bound to this artificial chemical. And so that is certainly the case for DDT. We know that it can bind to hormone receptors. It's been used for many, many years as a pesticide, and currently is used for disease vector control. However, we know that it's still used illegally in agriculture. And I actually just read an article saying that people who have mosquito nets in certain parts of Africa that are treated with DDT to help fight against malaria are using those nets in some cases for fishing in the waterways, and so they're contaminating their water systems with DDT. So it's a very problematic chemical and quite persistent. We're primarily exposed through the food supply, and this is particularly problematic in children who tend to get higher exposures. They pick up food off the ground, they stick things in their mouths. They also accumulate the chemicals more effectively than adults. And the elderly can be vulnerable because they may have some compromised health problems. Slide 12 shows a figure from the guide showing where high concentrations of DDT are found in human work around the world. So in blue are the blue outlines of the countries that have notified their intention to use DDT under the Stockholm Convention for vector control. In red are the countries where the highest DDT levels are found in human breast milk. And then, of course, you can see the countries that have both from 2001 to 2013. Slide 13 is a summary of why we know that DDT is an EDC. DDTs have been shown to act upon many different endocrine systems, including but not limited to thyroid hormones, estrogen and androgen systems, which are important for reproduction, in the kidney and in the cardiovascular system, which also make hormones. They're vulnerable to DDT. Insulin and the pancreas, and neuroendocrine systems, which are the way that the brain and the endocrine system communicate with one another, are perturbed by exposures to DDTs. And that has been shown in animal models, and there's also epidemiological data showing these same kinds of problems in humans who have appreciable levels of DDT in their body. We also know that exposure of the fetus and the child are particularly problematic, consistent with the developmental origins of health and disease hypothesis I introduced you to before. And the box shows some of the human health consequences of exposures to DDTs in reproduction, impairments in lactation and breastfeeding, diabetes, and certain types of cancer. And finally, in the guide, we chose one example of an endocrine disorder for which there's strong evidence for a negative health outcome due to exposure to that particular kind of EDC. And so for DDT, we picked type 2 diabetes, for which epidemiological studies in humans, looking at populations, measuring how much DDT and its metabolite DDE is in the body, and different endocrine diseases have found a strong positive correlation with type 2 diabetes risk. And this is strongly supported by animal experiments where we can expose animals and then look at the outcomes on type 2 diabetes. And it's also known that blood glucose levels are perturbed and animals become insulin resistant, which is one of the hallmarks of type 2 diabetes. Moving on, the next EDC class are electronics, which are, of course, are consumer products. And the chemical that we focused on were brominated flame retardants, BFRs. And of these, there's one class called polybrominated diphenyl ethers, or PBDEs. They're known to be persistent organic pollutants. PBDEs have been used as flame retardants in computers and electronics, in fabrics and furniture and building materials. And so we're exposed because they're released into the environment. They get into household air and dust. They may get into our food. Again, children are picking up food that falls on the floor and eating it. Any place there's dust, there's the opportunity for exposure. During processing of waste, as shown in this little picture at the bottom right, these flame retardants are also released, and there's occupational exposure there, as well as to people who are working with, like firefighters. When these materials are burning, they're released into the air in manufacturing and other related professions. And again, I show a little picture. You can see these chemical ring structures that allow the PBDEs to bind to hormone receptors. We know they're EDCs. It's been shown that they can interfere with thyroid hormone receptors in the enzymes that metabolize thyroid hormones. They also can bind to estrogen receptors and affect reproduction. And more recently, they've been shown to be associated with obesity. The negative health outcome we chose to focus on was adverse neurodevelopment. The brain is very sensitive to hormones. It's probably one of the most sensitive organs in our body. And during development, the brain develops under the influence of a lot of different hormones that are produced within the fetus, that are produced by the mother and transported across the placenta. And we also know that EDCs can, in many cases, cross the placenta and get to the fetus. So in humans, epidemiological studies have shown that PBDEs are associated with thyroid disruption, as I mentioned, but the thyroid hormone is very important for neurodevelopment. And so as a consequence, there's reduced IQ, diminished ability to concentrate, impairments in motor coordination, and some decline in cognitive functions. And animal studies, again, support what we know is going on in humans. Finally, for the food contact materials, we focused on BPA, bisphenol A. It's a synthesized molecule used in the manufacture of plastics and food containers. It was originally synthesized by pharmaceutical companies trying to design a pharmaceutical estrogen for a contraceptive. And they synthesized BPA, and they discovered it wasn't a very good contraceptive, but it turned out to be very good in these kinds of products, and so it got used for a very different purpose. But we all know that BPA can bind to estrogen receptors and activate them and have effects on target cells that have these receptors. So it's used in hard plastics, bottles, liners of canned food. Thermal paper receipts have high levels of BPA, and water pipes as well. And so we're primarily exposed by leaching of these materials from the food and beverage containers into our food, and they also accumulate in dust and from paper receipts that we handle. Slide 18, the science on why BPA is an endocrine disruptor. I mentioned it was synthesized to be estrogenic, and estrogens play absolutely critical roles in brain development in both males and females, in the mammary gland, in the reproductive tracts. They also, BPA can also affect thyroid signaling and energy balance pathways. So the negative health outcome we chose was behavior and reproductive health. From epidemiological data, disorders of reproduction and behavior, energy balance, and cardiovascular systems are associated with higher BPA body burdens. Ovarian function, such as development of follicles and ovulation, are perturbed. There are also links to endometriosis, polycystic ovarian syndrome, miscarriage, and premature birth. And animal studies have been very important to show that neurobehavior, anxiety, and aggression are increased by early life exposures to BPA. So let me end with a few big picture slides to summarize what I think is important about the science that we covered in this guide. First of all, there is no such thing as a safe dose. We know that natural hormones act at extremely low levels in our body. Our hormone receptors are exquisitely sensitive to extremely low levels of natural hormones. Therefore, EDCs, even low-dose exposures, are capable of acting upon our hormone receptors. And this concept is really important when you consider that there are periods of our life when we normally may not be exposed to a certain hormone. So think about a fetus that undergoes developmental changes, and throughout that developmental trajectory, hormones are turned on and turned off. And if you're exposed to a hormone disruptor during a period when there is not normally any activation of that hormone receptor, that can change the development of that individual. So we're very concerned that safety testing does not take into account these periods of developmental vulnerability, and that the determination of whether or not there's a safe threshold really cannot be conducted by the traditional toxicology testing I alluded to earlier. Furthermore, testing rarely considers mixtures, and so even if a very low dose of a chemical by itself doesn't seem to have an effect, when you start putting it together with all of the other chemicals we're exposed to, there can be quite many adverse consequences. In slide 20, I speculate a little bit upon what some of the problems of inferring cause and effect in humans. And so, as I mentioned, traditional testing is really inadequate for identifying EDCs. We know about developmental vulnerability and the potentially very long lag time to a disease. So trying to relate an early life exposure to a disease outcome years or decades later it's just really difficult to say with certainty there was a cause and effect. So this is why animal studies are so important, where we can control the environment and then look at the trajectory in animals that were exposed versus not exposed. We're exposed to complex mixtures throughout our lives, and everybody is different. We have unique genomes, different genetic predispositions for disease, different lifestyles, and we cannot do a controlled experiment. So in the last slide, I'd like to say why endocrinologists are confident that EDCs are an international public health problem. First of all, human studies, including twin studies of people who have identical genomes, show that the environment can influence even identical twins very differently. So we know the environment is very important for health and disease. We also know from high-dose or occupational exposure data that there are links between these chemicals and disorders. we base many of our conclusions in humans on outcomes from animal studies, which are conducted carefully, that are peer-reviewed, that include the appropriate control groups, and show that cause and effect relationship. We can also use cell lines to identify how an EDC might act. For example, a cell line that expresses an estrogen receptor can be used to test whether a chemical is acting upon this receptor. We also are confident about EDCs as a public health problem because of the increasing amount of epidemiological data in humans that links higher body burdens to increased disease prevalence. And that literature has really grown over the past 5 years and has become quite convincing. In the U.S., the Toxic Substances Control Act has 85,000 chemicals in its inventory, most of which have never been tested for health effects. And while they're not all EDCs, some of them are, and we're exposed to many of these chemicals. So I will stop here to leave time for questions.
Thank you so much, Dr. Gore, for your excellent presentation and for finishing in time so that we do have a great amount of time for our questions, which is a big part of what these calls are all about. So at this time, I'd like to invite questions from our participants. And if you'd like to ask a question, please press *2 to unmute your line. Please also state your name and affiliation, and we ask that you be brief so that we can get to several questions before we're out of time. So again, it's *2 to unmute yourself, and you can ask a question of either of our presenters.
Hi, this is Joe Rochester from TEDx. Thanks. Can you hear me?
Yes.
Okay, great. Thanks for the talk. It was really good. I have a question for Dr. Gore. Just a general question about the basic definition of hormones. You talked a lot about hormones needing to be released into the bloodstream, for signaling. But we know that there's a lot of other signaling pathways and things like neurotransmitters that don't get released into the bloodstream. And I guess my question is, should those things be included in regulation and definitions of hormones in terms of EDCs?
Right. So you're correct that we, as endocrinologists, tend to use a very strict definition that a hormone has to be released into the bloodstream. And we tend to define an EDC by its ability to interfere with one of those pathways. But we now, because we know that EDCs can also interfere with neurons and neurotransmitters and receptors in the brain that may be acting the way neurons act, by synapses and by synaptic transmission. So we are applying the word EDCs to those pathways as well. They might be more appropriately called neurotoxicants, but the same chemical can be both an EDC and a neurotoxicant. And it may even act by a similar pathway. For example, we have estrogen receptors in the uterus, we have estrogen receptors in the prostate, and we have them in the brain. So how a single chemical, let's say BPA, acts in the prostate may not be exactly the same mechanism as in the uterus or in the brain, but it may still be acting through the same hormone system, through an estrogen receptor. So the terminology is a little sloppy, but these same chemicals certainly have biological adverse effects in the nervous system, similarly to how they have it in the endocrine system, and in other systems as well.
Thank you. And do we have another question? Also, once you've asked a question, if you could press *2 to mute your line again, that'll be helpful so we don't end up with a lot of background noise.
Yeah, hi. My name's Stephen Seymour. I'm from Green Cape. I'm Cape Cod. And I had two questions, I guess. One of them was on the glyphosate. I saw that on the list, and I wondered what the evidence is like in support of that being an endocrine disruptor. And then on Cape Cod, we've had some of our groundwater tested, which we drink, and we found perfluorinated, like perfluorooctane sulfonate in the groundwater. And I am concerned about that, and I wondered if if there were hormone disruptor aside to those chemicals.
Yes. So I'm assuming your question is directed towards me. So
I think so.
Perchlorate is accepted as an endocrine disruptor, and it's primarily been studied for thyroid disruption, and it's quite a potent thyroid disruptor. So there is evidence there.
Yeah.
I know less about glyphosate, so I don't have authoritative expertise on that particular chemical. I know that there is a lot of interest in its effects on different kinds of tumor development, but I don't know the literature well enough to comment about how it may act upon hormone systems. So I'm afraid I'll have to just leave it at that.
Thank you.
Hi, can you hear me?
Yes.
Yes, this is Becky Long from Alaska Survival in Alaska, and I just wanted to say that a lot of us do not have running water, so we go into our water source and haul it in plastic buckets and then store them in plastic buckets, and so are we at risk for the leaching into our water source? Thank you.
Right. So one good thing about leaching is that the biggest contributor to leaching is heat. So I think you have some advantage being in Alaska that you are living in a much cooler climate than I am here in Austin, Texas. I would certainly take a look at what plastics are in your carboys or in your containers to see whether they include BPA or any of the more highly implicated chemicals in whether they're in the containers or not. And I would keep the containers away from heat as much as possible. I don't think you have much of an alternative to storing in plastics because you need water. What we tell people, what physicians who I've spoken to, I'm not an expert at this area, but the physicians that I've spoken to generally recommend not microwaving in plastics, trying to use ceramics or glass or other chemical-free types of products for storage. I don't know if that really is possible when you're having to haul water because they're so heavy, but it may be possible to at least choose the plastics that have fewer of the known endocrine-disrupting chemicals. I think I know that's not a very satisfying answer, but I think that something that scientists have become very interested in is that I've worked with a group of chemists who have learned about endocrine disruptors, and they're also they have children and they use plastics, and they're very concerned about these same kinds of questions. And so they're working very hard to try to design the next generation of chemicals that are not causing endocrine disrupting effects. And so the goal is to be able to introduce these chemicals into the consumer pipeline to make them much more prevalent in use for food and beverage storage containers. I think telling them they need to make larger storage vehicles is also important for them to hear. And I think what is very heartening is that they've been talking to the biologists who know how endocrine disruptors work, because they've heard of endocrine disruptors, but they don't know how to test for them. So they're working together with scientists who can actually test their chemicals and say, this one does not look like it's having any biological effects. So I'm hoping that within the next few years, you'll be able to have access to more of these products.
Dr. Gore, this is Diana, the moderator, and I just wanted to ask real quickly. You said choose the plastics that are, that don't have those chemicals. Are there numbers on the bottom? I feel like I heard at one time that numbers are safer. The recycle numbers? Yeah,
there are. I don't know. I don't remember what the numbers are now, but I believe that a good place that I saw that posted online was in the Environmental Working Group's website. They have a lot of consumer resources for people who are concerned about endocrine disruptors. They have lists of what fruits and vegetables are least likely to come into contact with pesticides, which ones should you really try to eat organic if possible, because it's harder to wash them off of the products. And they also have guidance about things like the numbers on the plastics.
Okay, thank you. We do have time for one or two more questions.
Yeah, this is Kai Schubert with DuPont. I have a question, if I may.
Yeah, can you say your name again and where you're calling from?
Yeah, my name is Kai Schubert, and I'm calling from DuPont.
Thank you.
And I have a question around if when we eat food, do we intake naturally occurring endocrine disrupting chemicals, and how does our body deal with these naturally occurring EDCs?
Right. So I think you're asking about things like phytoestrogens and soy and alfalfa and other phytochemicals. So yes, we do. And I think one difference between those chemicals and artificial chemicals is that humans and other animals evolved in the presence of these chemicals, and in fact, we evolved with the ability to eat and to digest them and to use them as part of our nutritional sources. So our body is capable of taking in these compounds and digesting them and using different components for different parts of our intermediary metabolism, our fuel metabolism. We did not evolve in the presence of chemicals. And so I think that we need to do a lot more research about how chemicals are digested or not, how they're passed out of the body or not. That's still quite a new field of research, and that is not the kind of research that I do. But the metabolism and the pharmacokinetics and pharmacodynamics of chemicals is an important research area. Some chemicals we're able to probably pass a lot of it right out through our bodies. Other chemicals get stored or get, especially persistent chemicals that can get into our fat tissues. Another feature of those ring-shaped molecules that I showed you in my slides is that along with being able to bind and interact with hormone receptors in some cases, they also are similar in composition to natural fats, so they can get into our fat tissues and often can be stored in those tissues for longer or shorter periods depending upon the nature of those chemicals. So I believe that there are some differences between the natural and the artificial chemicals because of those differences in our evolution on this planet.
Thank you. Do we have any other questions? If not, I have one, but I want to give others another opportunity.
Hi, I have one. My name is Janice Bailey. Can you hear me?
Yes.
Okay, I'm
Where are you
Janice
calling from?
Yes, I'm calling from Laval University in Quebec City.
Okay.
I wanted to say that I appreciated hearing about IPEN. I had never heard of it, so that was a lot of new information for me. And I also have a question for Dr. Gore that extends on the very first one that she received about this sort of sloppy definition of endocrine disrupting chemicals, which I can understand why it's become a lot broader. I wanted to ask about transgenerational or multi-generational effects. I know that that's some very new literature about these kinds of effects, so that, you know, beyond just early developmental exposure, that you might see effects on the offspring of that person, or say the animal. I think that's mostly it's been on animal studies that's been exposed. Can we still talk about that as kind of a far-reaching endocrine disruption? I just am really wondering for an academic reason, if you understand my question.
For an academic reason. Well, there certainly is some literature out there on transgenerational effects of EDCs, and for people on the call, what this means is that exposure to an individual can have consequences on future generations. So the consequences, first of all, depend upon when the exposure happens. So if the exposure happens at a time when we're fetuses and we're developing, and the cells that are eventually going to become the sperm or the egg cells, they're called the germ cells. If you get exposed during those early life periods, it can actually affect your germ cells. And those germ cells become the next generation. So there's evidence for a couple of different kinds of endocrine disruptors causing molecular changes to the germ cells that actually can be passed from one generation to the next. We've done some of that research ourselves and shown that 3 generations removed from the exposure to a class of endocrine disruptors, a fungicide, we saw behavioral differences 3 generations later, behavioral and hormone effects. So we're actually, by way of disclosure, we're doing that kind of research right now, and we've been consistently seeing effects in our laboratory, as have other labs. There's a little bit of controversy about the field. I think it's a really new field, and so we need to definitely do more research and compare the results across labs to figure out some differences in the outcomes. But I believe that this is a very biologically valid area of research that we need to consider. And of course, we can get the evidence in animals. It's harder to get that in humans because the generation time is decades. So trying to figure out whether your great-grandmother's exposure affects you is not so easy to infer. But we know in humans that nutritional status prenatally, which perturbs many of the same pathways actually that endocrine disruptors do, can have transgenerational effects on energy balance and obesity in future generations. So it looks like this is going to be translatable to humans.
Thank you. I think we are about out of questions, or out of time for questions, I'm sorry. But I would like to give both of our presenters an opportunity to make any concluding remarks that they would like to make. And Bjorn, maybe you could just touch on how this document might be used. I'm assuming it's going to be a great resource for the upcoming Conference of Parties to the Stockholm Convention on Persistent Organic Pollutants. I just wanted to give you an opportunity to make any closing remarks.
Great, thanks. This document is really a launch pad. The introduction to EDCs is a launch pad so that more stakeholders, that be civil society groups or decision makers globally, have a better understanding about the dynamics around EDCs, as Andrea went into. With the Stockholm Convention of Persistent Organic Pollutants, the focus of the Stockholm Convention is the aim to reduce with the goal to eliminate releases and exposure of persistent organic pollutants, because these are simply chemicals that are unmanageable. And as Andrea illustrated, there's no safe dose, and we have a current paradigm which is very much focused on risk assessment and dose making the poison. So we're very excited about this guide. We're very excited about the relationship with the Endocrine Society and having experts like Andrea and many others within the society communicating the dangers and the potential harm around EDCs so that we can actually elevate this into national policies across the globe. So basically the guide, it's basically a launch pad as we aim to translate and conduct webinars across the globe to really elevate the issues around EDCs, similar to what has been with EDCs. So with that, I'd also like to thank Andrea for a wonderful presentation of the guide. Thank you, Dan.
Thank you both so much for your time. Andrea Gore, did you want to say anything else before I wrap up?
No, I think I've said enough. But I did want to thank you for this opportunity, and especially to thank Bjorn, because I learned a lot from getting the IPEN perspective, that we don't always think about these things when we're in the lab doing the research. So it's so important to keep our eye on the people and regulatory policy.
Great. So thanks to all of our participants, and I did want to announce that our next Alaska call will be Thursday, May 21st, and will be a first-hand report from ACAT's Executive Director, Pam Miller, and others who will be just returning from the Conference of Parties to the Stockholm Convention on Persistent Organic Pollutants, the international meeting in Geneva, Switzerland. So please join us on May 21st for an update on international actions to ban production and use of some of the world's most dangerous chemicals. Some of these POPs, of course, are also EDCs, so very relevant to our discussion today. And I wanted to remind you that we do record these calls, and we'll notify you when we've posted the MP3 recording of today's call. And I'll try to address in a follow-up email some resources for the question about epigenetics, and also about plastics and sort of consumer choices through the Environmental Working Group website. So thank you all so much for participating today. If you have any additional questions or comments, please feel free to contact us. The phone number, 222-7714, or you can email me, Diana, at akaction.org. And thanks again to everyone. Have a wonderful day.